Pascal's triangle is formed by beginning with 1 at the top, and any given number in the triangle is the sum of the two above it. For example, if there is a 1 and a 3 next to each other, the number directly below and between them will be a 4, because 1 plus 3 is 4. The outermost edges of the triangle are always 1, because the number next to the one above them is nothing, which means it's 0, and so 0 plus 1 is 1. In Pascal's triangle, there are a number of patterns that form diagonally, pun intended. The first diagonal pattern is ones, just a big old line of ones. The second is just counting numbers, as in 1, 2, 3, 4, etc. The third diagonal pattern is triangular numbers. Triangular numbers come from the number of dots that form the triangle. One pattern that exists in the triangle occasionally is how an upper left number squared is equal to the number to the right of it, plus the number below them. The Fibonacci sequence is another number pattern and can be found in Pascal's triangle by adding the numbers upwards diagonally. Basically, you add the past two numbers in the sequence starting with 1 to create a kind of spiral pattern. The Fibonacci sequence occurs commonly in the natural world in plants and animals, some common examples being pine cones, the tail of chameleons, snail shells, succulents, and various other organisms.
To me, I think Pascal's triangle really stood out from all the other projects because when I was in elementary school, I think it was third grade, my third grade teacher during math, he would always have some new number pattern that he'd tell us about, and one day it was Pascal's triangle, so I figured this would be a good opportunity to learn more about it because we never really delved into it.
Yeah, I also find number patterns really interesting, especially doing Sudoku. I do that all the time, and so I just saw this and I was like, whoa, this is really interesting, and yeah.
One way to think of Pascal's triangle is sort of like a graph, with the columns being the y-axis and the rows being the x-axis. The first number at the top of the triangle is the 0 of the y-axis, and the first number in each row is the 0 on the x-axis. Therefore, the very top of the triangle is the origin, 0, 0.
Alright, now we're going to do an example problem. You have 16 different colored marbles. How many different ways could you just choose 3 of them, ignoring the order that you select them in?
The 16 marbles can be represented as 16 on the y-axis of Pascal's triangle. In addition, the 3 different colors of marbles can be represented as a 3 on the x-axis of Pascal's triangle. Find the intercept on the triangle of these two axes, or plug it into the equation. We're going to use the equation.
The formula to find any number in Pascal's triangle is called n choose k. This is because the equation allows you to find k items from a set amount of n items. N is the row, or x number, and k is the column, or y number. This formula can be used to find a certain number of different combinations of various items, which is how we'll use it for this example problem. The formula is the quantity n over k is equal to n factorial over the quantity k factorial times the quantity minus k factorial. Because you have 16 different colored marbles, you can plug in 16 for n.
We can now expand the factorials, and then simplify. And there you have it, 560.
No, that's a lot of marble combinations.
That's all. folks.